How much would a pinch of sand be worth to you? How about without the elements of gold or platinum mixed into it, just moon dust? A recent auction sold it for $500,000 for literally just a pinch of what's on the moon. But this apparently valuable minuscule amount of dirt was valued purely on its historical relevance. That pinch of sticky moon sand was from a small pouch that was collected by Neil Armstrong on the Apollo 11 mission in 1969. It was a huge piece of human history and a physical reminder of when man first landed on the moon, something taken from a place that no one else has ever been able to. Selling something from the moon opens a whole new debate around the legality of owning, using, and selling space resources from unclaimed parts of the solar system. Currently, the world abides by the 1967 Outer Space Treaty, which depicts the foundations of modern space law. This treaty, established so long ago, didn't predict the lucrative use of outer worlds for resource utilization. Although this treaty prevents anyone from claiming ownership of any new worlds, the potential value of these unclaimed territories is priceless. The moon is not only a stepping stone for future exploration into outer space, from which moon bases and possibly moon cities will one day thrive. For this purpose, humans will need to develop shipping bays and factories to support carriers to cross into new worlds. This project will need some good investments. Mining stations will provide the economy of the hypothetical moon city. There will be infrastructure and transportation to the moon and back again. All of this will cost a lot, way more than a reminder of when man first walked on the moon. So, apart from moon dust, what else could be valuable on the moon? There is value in the resources on the moon. We don't know the exact numbers, but it's estimated that there is more than was thought in the past. The Earth's natural satellite is believed to be abundant with iron, nickel, and cobalt, amongst many more. These minerals provide the potential for building Moon City itself. Just as in human history, cities around the world are a reflection of what resources are in abundance in their surroundings, and Moon City will be the same in that way. A gray city, walls made with metal, iron dust, and a lunar sand concrete, with great windows made from the unlimited sand available. The moon is also rich in silicon, an important ingredient in producing solar panel arrays. There's calcium to be used to fabricate the silicon-based solar cells, along with other ingredients found there, like titanium oxide, iron, and aluminum. The long-dormant lunar magma ocean residing under its surface holds magnesium. It's especially prominent within the lower crust and is useful for many purposes, most importantly for alloys with expected space travel. The production of steel requires many sources of carbon, crucially important for supporting the mega factories and for the many thousands of ships that will be built. Numerous rare earth materials are used in everything electrical. They continue to be more valuable, and their production is more prominent as technology progresses, especially in electric vehicles and wind turbines. Although rare earth materials are abundant on our planet, you won't find them in many concentrated areas. They are spread thin throughout the Earth, so locating and mining them is pretty costly, though they're more required with every year. The process of finding and mining on the moon is far easier and will be an important alternate source. Nitrogen, along with carbon, are important elements to support human colonization and farming, and ensure that the moon is not only habitable, but has a constant supply of food. We can obtain them within the moon's outer crust, so farming is possible there within sealed biospheres. Mining metals is a difficult process, but the result is worth it, not only for their value, but also because of the valuable byproducts that you can get in the process of extraction. It can be oxygen, available for breathable air within the city, and hydrogen to ensure water for the plants and for drinking. Valuable resources will not only come from within the surface of the moon. Its potential for solar power is so huge, it will ensure harvesting the solar waves to power Moon City. The fact that it lacks a thick atmosphere and that there's no interruption of weather patterns removes some major obstacles that are present on Earth. The energy created could be sufficient for all requirements on the moon, and, in the short term, may also help solve many of Earth's power concerns. Extracting resources and manufacturing requirements will be significant as time carries forward. As Moon City is going to grow, and humans will reach further into outer space, it will require more and more energy. The output to factories and production on the Moon will become so elaborate that they will need alternate sources in reserve. Atom-powered fusion will be an important source of energy with no dangerous byproduct. It will be safer than the technologies of today that use uranium. Feeding this kind of fusion will require the most valuable of all resources found on the Moon, helium-3. It's not only present on the Moon, but can also be found on Earth. But the amount is super limited here due to our planet's strong magnetic field. It ensures life can thrive on Earth, but at the same time deflects the solar winds from the Sun, making it difficult for helium-3 to be produced. The Moon has no magnetic field and has been absorbing the solar wind for billions of years, constantly building up an endless supply of helium-3 in the process. It absorbs the winds into the top layer of solid material on the Moon, also known as the regolith. The regolith is spread all over the Moon, and it makes the extraction of the helium-3 an even more valuable action. Mining it would also include mining all the other valuable minerals in the process. The value of helium-3 is so substantial that many countries and companies are determined to gain a foothold on the Moon. The value of this alone is within trillions of dollars. Some people believe the opportunities that helium-3 will give humanity are immeasurable. There will be unlimited energy providing millions of jobs in Moon City. That energy will also support the Earth's needs. Only 25 tons of helium-3 could power the United States for an entire year. This resource will provide the potential to power all of Earth for thousands of years and have enough energy required to help guide humans further into space. It will enable the construction of spaceports around Earth and allow for a more efficient journey from Earth to orbit. From there, people will be transferred to shuttles destined for other locations throughout the solar system. The lengths of spaceflight will be reduced significantly, creating more frequent flights toward Mars. Further ports will be erected around its orbit, supporting new colonies to reside on its surface. Mining colonies with the support of endless energy will spread throughout the red planet, with more valuable resources residing within its red soil. This new age of colonization in the solar system will cause a domino effect as it continues to push further, advancing with every generation of vessels developed. Travel will get more and more efficient as the helium-3 will continue to assist in advancing the technology of spacefaring ships. Outposts of all purposes will develop on the moons of Jupiter and Saturn, from researching for potential habitability for life on Europa or Enceladus, to continuing the tradition of extracting valuable resources in every location. The Moon will continue to find ways to provide the energy that's needed for terraforming new worlds. It will assist in warming Mars and powering an artificial magnetic field. It will also help with constructing a large reflector that will be able to cool down Venus. All of these will be the foundations for creating further livable locations for future generations of humans, all thanks to that initial source of energy from the Moon. It's difficult to put an overall price tag on the Moon, even when you know that there is value in harvesting its resources. The value of what the moon dust really amounts to can't be determined by a monetary figure, but by its potential to influence what humans can create as we continue to progress as a species.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail. And every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium. And our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter, high tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, How about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The 2 planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the 2 planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the 2 planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color. Very beautiful bluish-green. If either of these planets replaced the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably louse up the internet too.